Let us explore Pythagorean theorem. A square plus b square equals to c square. Well, in a right triangle, let me draw one here. Let's say this is our right triangle where we have two sides which are A and B. A and B. Then the hypotenuse, side opposite to 90 degrees, is C related with A and B. And the relation is that C square equals to A square plus B square. Now this A square plus B square equals to C square is so commonly used for any right triangle that we don't even think about proving it, right? We just take it for granted. Now here is an illustration which gives you an idea of how we can actually get to this relation. A square plus B square equals to C square. So what we have taken here is that we have two squares. Now let's call this as square A and the other one as square B. Now these two squares are congruent squares. So what we have done here is we have connected few lines inside the square, making a square within a square. So let's say the length of this is divided into two parts, that is A and B. If side length of my square A is A plus B, then area of the big square will be A plus B whole square. Well, area of square B will also be A plus B whole square. What is interesting to note here is the way squares are inscribed in these two squares. So that is kind of different. But what we are going to figure out is that the inscribed squares in both the squares have exactly the same area. Try to think about it. Do they really have same area? The squares inscribed have been shaded in orange color. Have a look at it. Let's try to prove it mathematically, right? So what is the area of this colored portion inscribed within the square with side length of A plus B? Well, let us assume that we don't know the length of the inscribed square. Let it be C, right? Then what is the area of the inside square? Let me call this area as A1, right? In that case, A1 is equal to C square, right? Since all these sides are equal for me, area of A1 is C square. But how much is this C square? Well, this should be area of outside square minus area of these four triangles, correct? So it should be area of outside square is how much? A plus B is the side, and therefore area of outside square should be A plus B whole square, right? So that is the area of big square, square A, minus four triangles which seem to be congruent. So 4 times area of each triangle is how much? Half base into height. So let me write this as half, and base, let's consider this triangle, right? So if this is base A, then the height is B, right? Or for that matter, you can see this triangle. So the base is A for me and the height is B, right? And all these have same base and height. So the area of each of these triangles is half base, which is A, right, times height, which is B. So therefore, area of the inside square will be A plus B whole square. Outside square area, take away 4 times these 4 triangle areas, right? So that gives us A plus B whole square. I can expand. So it tells me A plus B whole square is A square plus 2AB plus B square, right? That is what A plus B whole square is. And now let me expand this portion, which is 4 times half is 2, right? AB. So that gives me 2 times AB. Now A square plus 2AB plus B square minus 2AB. Now plus 2AB minus 2AB becomes 0. And what are we left with? We are left with a square plus b square. Wow! So that is how we get c square equals to a square plus b square. So what we proved here is that c square is indeed equals to a square plus b square. Now c square is the area, therefore c should be how much? Square root of a square plus b square. Perfect, right? So that is kind of a proof for your Pythagorean theorem, right? Now I hope you appreciate this part. Now here's another look at the same square, right? Let's look again into this. Now this time what I did was that I reorganized my triangles. So I have this triangle, so I brought the other one from here and placed it right there, right? So I get kind of a square here. Do you see that? Now this triangle, I brought it down like this. So we kind of reoriented our triangles. So now let's look into the figure B, which is exactly same square which we just discussed. Same as figure A, right? And area of each triangle here is also same. It is half A times B, right? Let us say this side is B for us and this is A, correct? So area of each triangle is half A times B, same area. And there are 4 of these, that means 4 times half A plus B. So the area of shaded portion should be exactly same what we did. Well, here we don't even have to do that math. You know why. Now in this, since the sides are A plus B, so look at these sides. So side of the square is A and A. How about side of this square? It is B and B, right? Now we know one thing, that the area of shaded portion in both the figures is exactly same, right? Because it is area of big square, take away area of 4 small squares, right? Same statement. And what is the area of orange portion here? So let me say area of shaded portion is A square plus B square, right? This is A square area and this is B square. Perfect. Since A1 is equals to A square plus B square, same area, we get, so we know A1 equals to A square plus B square. So C square equals to A square plus B square. That's kind of a neat way of looking into the same square. So by dividing any square in general in combination of A and B, we can prove. Now since A and B could be any numbers, it becomes a general theorem and it can be applied to any right triangle. Do you see that? So why are we applying it to the triangle? Since we have a triangle here, right? So our idea was how to relate C, the hypotenuse, what we are trying to call now, with the given sides of right triangle. Now if you go back and look into the triangle, you will observe that the triangle is a right angle triangle with side A and B. And we figured out C is what? C is A square plus B square square root, right? So from here we can write C equals to square root of A square plus B square. Well, that is how we can really look into it. And I hope it helps you to understand and appreciate Pythagorean theorem. So there are so many different ways to look into it. And now we will see enormous applications of Pythagorean theorem. I hope you appreciate it. Thank you. And now let's enjoy working with examples and applications of Pythagorean theorem. Thank you and all the best.